Now let's look at another feature from behavioral graphs. Local maximum, local minimum, and absolute maximum. So another feature we would like to focus on is the location and value of the maximum and minimum. Well, visually on a graph, we can see where the maximum and minimum are located. There are some mathematical ideas we need to be aware of. Okay. So first, there's two types of maximums, local and absolute. Let's look at a local. Definition of local. A function f of x has a local maximum value at x. So a is some position, that's where it's the local maximum. If, when I enter that value into my function, it is greater than x, well, what's x? For all x in some interval from c to d, where a is in that interval. So a is somewhere in here, and no matter what I try to enter besides a, all the other values are not bigger than that one. That's just a. Note that the interval CD is made as what? Well, I have it over here as narrow as needed around the value a. So we want to make this interval, like people try to make it big, we go, no, actually you make it small. And say, well, I can make it bigger and it's still true. That's great. But that's not what we're saying. Yeah, well, it's true. You're saying it's true. It's actually making a small, we can make the interval, how small do we need to make the interval so that this is true? So we don't care about the actual numbers. We know that all we care about is locating the maximum value. And a function has a local minimum at x equals a if the opposite is true. When I enter that value into this function, when I look at all the different other values in some interval c to d, where a is in that interval, we have that f of a is just smaller than anything else in that interval. And again, note that node CD is made as narrow as possible around the value of a. So let's look at an example. Another thing that we have to be aware of is, note the local minimum and maximum cannot occur at an endpoint. So we're not going to look at endpoints. Only within the value has to be within some interval. So in other words, we're not going to consider if it's a C or a D. Only the A has to be somewhere in between. All right. So, and now I'm going to make a distinction. I think this is really important. Some books make really a big deal of it, others don't, ours does not. But where is the location of the local maximum? So you must understand that when you look at a horizontal and this XY coordinate system, the x-axis tells you where, while the y-axis tells you what you're looking for, or what is it that you're getting. And if you look at graphs, like for example, the stock market, you see pictures of the stock market going up or down, or whatever. This axis tells you what the stock market value is, and this tells you is the when. But again, the when or the where, depending on this time or location, not your physical location. But again, this axis just tells you where, when it's happening, and this one tells you, when you read it, it tells you what it is that you're getting at that point. So keep that in mind. So for example, where is the location of the local maximum? All right, so now we're looking for the location of local maximums. Well, again, I'm looking locally and I see that this is a high point. And again, a high point, if I just kind of create a little interval. How big? Again, doesn't matter. I'm not, all I care is to make sure I recognize that's a high point, and sure enough, in that little interval, that's a high point. So it's local. So where is that? So that means that I need to tell you the location, which is an x value. Let's say make this x and y. These are not marked right now, but oh yeah, they are. Not good though. So I'm going to write, look, there's a local maximum when x equals, looks like 2. Anywhere else? No, what? It's not a maximum? Right, but maximums cannot happen. Local maximums cannot happen. And endpoints. This is an endpoint. Again, the entire domain of this is negative infinity. Sorry. negative infinity to 10. So that endpoint, and stopping at 10 exactly. So we're not going to include that. Okay, so that's the only location. And what are the values of the local maximum? So again, that just means that what's the y value? So the value of the local maximum is looks like 1, 2, 3, 4, yep, 2. So the value is 2. So what indicates the value, the actual value of the maximum? Where it's happening? Where's the location of the local minimum? The exact opposite. Now local minimums, let's say I'm looking here. So here's a tiny little interval. And in a tiny little interval, it looks like when I go down, I finally reach a minimum, a small value within that interval. And that's happening at 4, looks like, x equals 4. So at x equals 4, there's a minimum, but that's not the only minimum. So I'm going to use the notation where it's the x value such that one that I found is at 4. And where's another one? Again, if I create a little interval around that, I can see that right here is also a minimum locally, and that's happening at 0. So notice that there's other y values smaller than it, but I'm saying locally within this little interval, that is the smallest value within that little interval. Same thing. In that little interval, that's the lowest value. And that is where, and what are the values? So now here is the value that makes it small for that little local place. And here for this one, the y value is 0. And here the y value in this local minimum is 1, 2, negative 2. So negative 2 is the actual value. Now look at another thing, points. What points are the local minimum? So now notice, I was trying to make distinction between where and what. Your book doesn't quite do this. And your book sometimes just goes into, hey, just give me the point, the location. So in that case, I'm going to give you just an ordered pair. What points are the local minimums? Well, local minimums occur at 2 different places, and the location is 0, 0. And that's 1, and the other one's right here, which is at 4, negative 2. So 4, negative 2 is another one. So these are the points where the local minimum is located. But at that point, I'm giving you the where and the what, the where and the what, the whole thing.